Okay, so we're looking at the other trig functions that you need to be able to manipulate. The formulas are basically the same as with the sine. So you're looking at this example here. Okay, so try to work out what the amplitude, period, translation and phase shift are. Phase shift. And when you're ready, come back to me. Pause and have a go, and then come back when you're ready. Okay, the amplitude is 2. The period, there's no coefficient, so the period is 2 pi. The translation is -1, and the phase shift is pi on 4, but it's going backwards because there's a plus number, so it's going to be shifted backwards, and because the coefficient's 1, we don't have to worry about any other changes. Okay, so let's have a look at the sketch. Okay, so basically the original cos function starts at the highest point, which is going to be 2 and going down to -2. The period was 2 pi, so we can put that down as 2 pi, pi on 2, 3 pi on 2. And so basically that hasn't changed, but the -1 moves things down. But we're also going to be moving the graph backwards. So, okay, so there's minus pi on 2 just to get the symmetry. So basically everything's being shoved back half of one of the graduations and then being moved down. So this one is being moved, this point here, change colours. So this point here has been moved back pi on 4 and then down 1. Okay, so basically the new, it's like the new floor. That's like the new x-axis. Okay, so this point here has been moved back pi on 4 and then moved down to that spot. This point here has been, this point here has been moved back pi on 4 and then down 1, so now the bottom's -3. That point there has been moved back and down, so that's about there. What other point? That point there has been moved back and down. Okay, so I've got, let's see if I can draw that together. Okay. Up and into there, and then just keep the symmetry going. So it's going to go through there. Not sure what that value there is, so we don't have to worry at this stage. We'll be using Trig equations later on to actually get some values. So I'd say it's not going through the origin, it'd be some other value, but we won't worry about that at that stage. Okay. Alright, let's have a look at the next one, which is a tan, I think. Okay, so now we're looking at y equals a tan bx plus c plus d. Now, because it doesn't, because the tan graph doesn't have axial amplitude, basically the graph looks like that. It doesn't actually have an amplitude, so the a doesn't change the amplitude, but it does has an effect on the steepness. Okay, so it does actually change the shape. So if you go to Desmos again, and you just type in y equals tan x and y equals 2 tan x, and you can see that the shape does change in terms of its steepness, but it still has the same asymptotes. D is still a translation, so instead of the curve perhaps going through at 0, it's going to actually go through at a new number, up or down. The B value still affects the period, but rather than going at 2 pi, it's going to get pi on B rather than 2 pi. And C is still a phase shift, and again I've put a plus sign there, so you take the opposite and you divide by the coefficient of x. Okay, so copy that and come across when you're ready. Okay, so again, like as I said, Desmos is a good sketching tool. We're covering tan, but I'm not saying I'm going to test tan in a test situation, but you just have to be aware of it. Okay, so we'll go through. So the amplitude is not, we don't have one, doesn't have an effect. The period is going to be pi on 2. The translation is going to be +1, 1 up, and phase shift. Oh, we've done the no, we haven't done the phase shift, sorry. Phase shift will be pi over 2. Okay. So, normally, excuse me, beg your pardon, that would normally be pi on 2, so now we've got pi on 4, minus pi on 4, and that's 3 pi on 2. So normally, the function would look like that. This is the normal function for tan x, not anything else. Okay. Alright, so backing on just to have a quick thought. Because the phase shift is pi on 2 and the period's pi on 2, then everything's just going back the same distance. So there's actually no change to these asymptotes. Like the curve's not going to go through anything different. So basically the curve's the same, except we just got to move everything up 1, and so basically 0 becomes 1, and so it's going to look something like this. And again, I suggest you draw it on Desmos just to have a look. Again, the 3, it's hard to show on the graph how steep it is compared to the normal one. But again, and also on Desmos, it doesn't show the values as pi on 4 because it's actually showing pi as 3.14 and things like that. But that's basically it. It's highly unlikely I'll give you a tan graph. It would more likely be a sine and a cos. Okay, so there's plenty of practice for these ones on the worksheets.